experiment. What we decided to do was if someone could jump higher with their dominant leg or non-dominant leg. Our hypothesis was the person who jumped with their dominant leg would jump higher than the person with their non-dominant leg. So the materials we used for this was one large measuring tape, a 1 through 10 card for subject randomization, a spreadsheet to record results, and a wall. Roles. Andrew was a data collector. Aji was the card distributor. Ethan, he talked about the experiment to the people, and Bilal answered any questions that they had about the experiment. Okay, the procedures. Audrey passed out the cards to randomized subjects. Subjects is taken out to the hall, and we will measure the full length of their body with hand extended. Subject will jump with their dominant foot only first, without a running start. We will measure where their hand touches. Subjects will now jump with their non-dominant foot without a running start. We will measure where their hand touches. Data is recorded and analyzed.
So this was our research question, as Aji said before. Which leg can you jump higher on? We decided that this experiment it can be important because it can help you in life in many ways. One of which can be in a basketball game. If you know which jump to put on, it helps a lot. Or if you're in an assault, you know which foot to kick with because your dominant leg will definitely be powerful and have more speed in it. And our experiment is just a test to see if people can jump higher on their dominant leg versus jumping on their non-dominant. We hypothesize from this that yes, indeed, you can jump from your dominant leg. Now, our experiment design was while conducting this, we decided that it is a well-designed experiment because it does involve the three characteristics of what would be a well-designed experiment. We had a sufficient amount of numbers based school-wide obviously, and we also had a control group, and we randomized all subjects from a popular drum bag. Unfortunately, there was no subject blind or evaluator blind considering the fact that the subjects kept asking way too many questions, and their lack of cooperation was also misfortunate. And this experiment also couldn't maintain evaluator blindness because of the poor time we had in conducting this experiment and not enough time to find any more replacements. The lurking variables are as follows. Laziness, tight pants is what a subject complained of. Another subject complained of an injured ankle, while another one jumped right on with both feet and ruined the experiment. One subject also complained of not being able to run, and many people prefer a running start in order to jump higher. And the majority of the subjects also complained of a weak balance. They couldn't keep their balance against the wall, which affected their ability to jump high.
So now let's take a look at the data that we collected. First is the non-dominant jumps. The far left column is the height, their original height before the jump. The blue column is their jump length and how many inches they jumped. And the pink column is the height of the jump. And to continue, these are the data for the dominant jumps. Again, height is the orange column, jump length is the blue column, and height of the jump is the pink column. So now here is our dot plot for our non-dominant jumps. As you can see, most of the data is clustered around the 7 to 9 area, with some outliers around 11 and 12 and 4 and 5. Now here's the dot plot for our dominant jumps. This is much more collected. As you can see, all the way from around 7 to 12, the data is staggered. And then here's our histogram. As you can see, most of our data is centered in the middle around 0, and the population difference is around 1.1. Statistics. So for non-dominant and dominant leg, the mean was higher for the dominant leg, so the jumps there were much higher. And then for standard deviation, it was higher for non-dominant.
All right. So our analysis, we concluded that yes, in fact, those who jumped with their dominant legs proved to jump higher than those who did not jump on their dominant leg. From the statistics in the previous slide, our hypothesis proves correct. However, we cannot conclude in general that people would tend to jump higher on their dominant legs because we lack a sufficient amount of subjects worldwide. But it is decent to conclude on our smaller school-wide basis, the difference of means computed at was 1.125. Henceforth, against proving our hypothesis, again, our statistics and graphs dot plots were presented in the previous slides. Credits for the dot plots go to Ethan, who handmade the entire graphs. All right. So this basically is saying what our whole experiment was about and what it proved to be true about our hypothesis. And that is our presentation.